Hello everyone, welcome to today's class. We'll continue our topic straight lines and we'll discuss few lost points that are relevant from straight line point of view. One thing that we have to now understand is that we can find distance of a point from a straight line also directly without going through any trouble. There's a format, or as such there's a formula for it. Okay, suppose this is a straight line. Okay, and you need to find distance of this line from any point. I'm not just saying from origin only, it can be from anywhere, let's say from here. So you need to calculate the perpendicular distance, this t, from this point. Let's say this is x1 y1. Okay, so value will be known to us and the equation of line will also be known to us. Let's consider a standard form, ax plus by plus c equal to 0. Okay, in this scenario we are talking about distance of a point from a line, and the formula is d is equal to ax1 plus by1 plus c upon square root of a square b square. Okay. How do you learn this? Basically what we have done, the numerator part, if you look at, you just put the value of x1 y1 in this equation. Simple enough. Okay, and denominator is square root of a square b square, the coefficient of x, the coefficient of y. Okay, in this line. Similarly, there is one more format that is regarding distance between two parallel lines. Okay. So let's say this is one line, this is another, this one is another line. Okay. They must be parallel, so let's make them parallel. Looking like parallel, no? The equation of first line will be ax plus by, a1x plus b1y plus c1 equal to 0. The second line, because the lines are parallel, so basically what will happen is slope will be same. So interestingly, one fact that the coefficient of x and y will be same means for this line also you will have a1x plus b1y. Okay, but but your c can be different. So one concept also, like if your coefficient of x is matching, if your coefficient of y is also matching, the two lines are parallel, directly you can say this. Okay, so I'll give this as a concept, coefficient of x are equal, no, I'll one conclude it, coefficient of x and coefficient of y are equal for two lines. If this happens, then lines are parallel. Directly, without checking the slope, you can directly conclude this. Okay, in that scenario, the formula for distance between these two, okay, that distance d is given by modulus of c1 minus c2 upon square root of a square plus b square. Okay, so these are the two formats regarding the distance. Let's see few questions to understand. Is given you one point, that's your x1 y1. He's asking you to calculate the distance from this point for this line. Okay. From this line you have to calculate. So let's first of all rearrange this in the standard form. So 12x plus 72 is equal to 5y minus 10. So let's rearrange. So 12x minus 5y plus 82 is equal to 0. That's the standard form of the line. Let's say L1. And point is minus 1 comma minus 1, from where you have to calculate the distance. Now distance is, how do you get? Modulus of, put the point in the equation. So 12 into minus 1, okay, plus, not plus, minus is there, no, sorry, minus 5 into 1 plus 82, okay, upon square root of 12 square plus 5 square, modulus of it. You can use directly format also, ax plus b, ax1 plus by1 plus c1 upon square root of a square plus b square, sorry, c. So my recommendation again, go for the simpler method, put the point in the straight line directly, okay, forget about this equal to 0. Let's calculate. Minus 12 minus 5, you will get minus 17 plus 82. This will become 12 square 144, 25, 169, 13 in the denominator. Okay, so that's 5 and 7, not 6, 65 by 13, and that's 5. So 5 units is the distance. Okay, 75 and 65, correct, 5 units. So the distance from of this point from this line is 5 units. Direct use of the distance formula. Okay. Next, we'll talk about the parallel line. Okay. Okay. Look at the coefficient of x. Although the question is saying that find the distance between parallel lines, but suppose the question asks find the distance between the lines, you can see 15, 15, plus 8, plus 8. The coefficient of x and y are same. So line has to be parallel. This is your C1, that's your C2. Formula is D is equal to modulus of C1 minus C2. So minus 34 minus 31 upon square root of 15 square plus 8 square. Okay. That gives you minus 65, 30, 30, 60, yeah, minus 65. Modulus square root of 15 is 225, 8 is 64, that becomes 25, 64, 289, 17. So 17 come here. If you do the modulus of a negative quantity, it becomes positive. So 65 by 17 units. I'm writing. Okay. For the second part, the equation first of all needs to be rearranged. So this will be Lx plus Ly plus P equal to 0. Second equation is Lx plus Ly minus R equal to 0. These are your C1, C2. Positive, negative you have to consider. Okay. C1, C2. Distance is modulus of C1 minus C2. So P minus minus Q, P minus minus R. C1 minus C2 upon modulus of, square root of L square plus L square. Coefficient of x, coefficient of y. So that gives you P plus R upon root 2L. Okay. All right. No variation, direct answers. Straightforward. Now, before doing any further, first let me give you one idea that will help you with all the formats. Okay. So far what we have done is, on the basis of given condition, we have found equation of line. But what if equation of line was already given to you, and then the question asks you what is the slope? Okay, so I'm putting this under the heading how to identification of slope, because slope is the one most important parameter that you need. So if the equation of line is given, you should be able to identify slope as quickly as possible. And what else you need? Intercepts. Okay, slopes and intercepts, these are the things you should be able to identify. Okay, all right. I'll explain this. This is not a formula. First of all, I'll explain this with the help of an illustration example. Let's say equation is 2x plus 3y is equal to 4. Okay, and I ask you what's the slope. Okay, in order to get slope, what you do is you convert this into y is equal to mx plus c. Means you try to generate the expression of y. Whatever is the coefficient of x will be your slope. Whatever is this c will be your y-intercept. So if I generate y, it will be 4 minus 2x upon 3. Let's split the denominator. 4 by 3 minus 2 by 3x. I told you that the coefficient of x, that's your slope, m, and this is your y-intercept. Remember, this was y-intercept, means where it cuts y-axis, y-intercept. If it is coming positive, means it is intersecting above x-axis, and if it is coming negative, it is intersecting below x-axis, y-intercept. Okay, this is how you identify slope. This is standard way. What if you want to do this very quickly? Okay, you want to save time, you want to do this. So I'm giving you a direct sort of not exactly a shortcut, it's basic idea, same as this, that m is equal to negative of coefficient of x upon coefficient of y. Okay, this will help you a lot. This will help you to directly calculate. So if we look at the coefficient of x, that was negative of 2 and coefficient of y was 3. As simple as that. So I've given you the basic also. I've given you a shortcut also. Your call, whatever you want to use. This is also not very lengthy. It's just that this is way fast. Okay. Next is I'll use the same equation to identify intercepts. So 2x plus 3y was equal to 4. I want to know where this line cuts x-axis and y-axis. Of course, there is one standard way to do that. That's putting x equal to 0. You'll get where it cuts y-axis. You put y as 0. You'll get where it cuts x-axis. But directly, if you want, you convert this into x upon a plus y upon b is equal to 1. Whatever is the denominator of x, that's your x-intercept. Whatever is your denominator of y, that was your y-intercept. Okay. So in how will we get 1? More importantly, right side is 4. How do we get 1? We divide both sides by 4. So 2x by 4 plus 3y by 4 is equal to 1. But look at the format. The numerator should have only x. So what do we do with this? 2. We'll put it in the denominator's denominator. Means x is equal to 4 by 2 plus y upon 4 by 3 is equal to 1. Okay. So basically, if we still rearrange, say the x upon 2 plus y upon 4 by 3 equals to 1. Now I know where it cuts on x-axis. So x-intercept I know. Second, intercept, and where it cuts y-axis I know, y-intercept. Okay. Moreoverly and majoritively, you will be required to use this m a lot. Okay, so remember the shortcut, coefficient negative of coefficient of x upon coefficient of y. As simple as that. Let's look at the application of this concept that I've taught you now. Okay. Okay, first question based on this ideas. Find the equation of a line. So still we are talking about equation of line. Parallel to a given line passing through point this. This time he has not given you slope, but he has given you that there's a line 3x minus 4y plus 2. It is parallel to some other line, okay, and it is passing through minus 2 comma 3. If only I know the slope of this line, I can solve it. And if the two lines are parallel, let's say this is m1, this is m2, the two lines are parallel, so m1 is equal to m2. All right, now get the slope m1 directly that I taught you. m1 is negative of coefficient of x minus 3 upon coefficient of y, which is minus 4. So that's 3 by 4. So that means this should also be equal to m2. Now you know m2, slope of this line and passing point. Same thing that we have discussed in the last class. Y minus y1, passing point 3 is equal to slope 3 by 4. X minus minus 2, that's plus 2. I'm not rearranging it. You can rearrange and get your final answer. Okay, you'll get the format as ax plus by plus c equal to 0. But I hope you get the gist of it. Okay, what we have to do, the question was saying that the two lines were parallel, so I used m1 equal to m2. I calculated m1 quickly using this. Okay, all right, let's do the next one now. Okay, next question says find the equation of line, this time perpendicular to a line. Last was parallel, this time it's perpendicular. So this is a line, suppose this is x minus 7y plus 5. This is the line. We have to find equation of a line which is perpendicular to it and having x intercept. This line has x intercept as 3. Now this is slightly weird. X intercept, how will we use this? We cannot analyze this like this, so somehow it is related with x intercept, y intercept. So I'll better draw the xy axis, so you should be able to understand it. Although I can do it without it, but you might not be able to comprehend it, what I've done directly. We have a line with intercept 3, so 3 intercept. If nothing is said, then it is by default positive 3. Okay, means here it is intersecting, and there is a line which was perpendicular to it now. Okay, the two lines are perpendicular. Okay, having x intercept as 3, and this line will be x minus 7y plus 5 equal to 0. Same idea. We know this is x intercept, so we know this passing point indirectly. Is it 3 comma 0 or not? Because it is intersecting on x axis, so this point has to be 3 comma 0. So now we have a passing point. That was the idea. Half passing is from 3 comma 0. If only we know the slope of this, we can easily calculate. Same thing we have to do. Consider this slope as m1, consider this slope as m2. The lines are perpendicular. This line L1 is perpendicular to this line L2. L1 perpendicular to L2, which implies m1 m2 equal to minus 1. The condition of perpendicular lines. Just solve it. m1. How will you get m1? As quickly as possible. Coefficient of negative of coefficient of x 1 divided by coefficient of y, which is minus 7, 1 by 7 into m2 is equal to minus 1. You get m2 as minus 7. Okay, so if you get m2, you have this line slope and you have passing point. Can we solve? Y minus 0 is equal to slope m x minus passing point 3. So it is coming y is equal to minus 7x plus 21. So y plus 7x equal to 21, or take it to the left side, minus 21 equals to 0. Okay. Done. So that was the idea. Perpendicular lines, m1, m2 equal to minus 1. Get your m1. From that condition, get m2. Slope you know, passing point you know, you can deal with it. Let's see more. Okay. This time he is asking us to find angle between two lines. There was a formula for angle between two lines, that was tan alpha. That's m1 minus m2 upon 1 plus m1 m2 modulus inside. How? Now quickly get for this line m1, this line m2. Using the same concept, m1 will be coefficient of negative of coefficient of x upon coefficient of y. m2 will be negative of coefficient of x upon coefficient of y. Okay. So that's m1 is equal to minus root 3 and m2 is equal to minus 1 by root 3. Put it in this equation. So minus root 3 minus of minus 1 by root 3 upon 1 plus minus root 3 into minus 1 by root 3. That's modulus of minus root 3 plus 1 by root 3. Denominator will become 1 plus, cancel this negative, negative, cancel root 3. So 1 plus 1, 2 basically. Numerator, let's solve this. This is root 3 becomes 3 minus 3 plus 1 by root 3 and denominator is 2. Okay. Let's solve it further. So basically we were calculating tan alpha. Tan alpha is modulus of minus 2 by root 3 and that 2 becomes like 1 by 2 if we take it in the numerator and reciprocal it. Cancels it. So tan alpha is equal to minus 1 by root 3 modulus. So tan alpha is 1 by root 3. So alpha is 30 degree. Okay. But the question is saying find angles. Look at the word plural. Now how do we do that? See, for this you just need to analyze one thing. If two lines if two lines intersect, you will always have one acute angle that we have already calculated, alpha 30 degree, and another one as obtuse. So that will be 180 minus alpha. Okay, so that's 150 degree. So the answer is alpha is 30 degree, but the question is saying angles. So the angles are 30 degree and 150 degree. 30 degree is pi by 6. This is 5 pi by 6. They can give you answer in the radians also, no? Okay. Correct. Okay. 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 All right. Let's see the next one. It's saying the line through these 2 points intersects this line at right angle. the line through these points. The point is, again, he's saying that there are 2 points on a line h comma 3, 4 comma 1, and it intersects another line at right angle. This line's equation is 7x minus 9y minus 19 equals to 0. Okay, he's saying find h. Okay, 2 points we know for this line, let's say L1. 2 points we know. Can we calculate its M1? This is another line. We can directly calculate its M2. And these two lines, L1 and L2, are perpendicular. So again, same idea, M1 M2 equal to minus 1. See how many times this concept is being repeated. Look at the importance of it. So M1, let's calculate M1. 2 point are given, so we'll use direct formula, y2 minus y1. So 1 minus 3 upon 4 minus h. M2, use the direct concept, coefficient of negative of coefficient of x upon coefficient of y is equal to minus 1. Cancel this. So you'll get this becomes minus 2 upon 4 minus h into 7 by 9 is equal to minus 1. Negative negative again cancels. So you get 2 by 4 minus h is 9 by 7. Cross multiply. 14 minus 14 equals to 36 minus 9h. H will come in fraction. 9h is equal to 36 minus 14. H is equal to 2, and this is also 2. 22. Okay, 22 by 9. Weird value. I was expecting a good answer out of it. Let's recheck. So yes, this was okay. Anyways, fractional value, let it be. All right. Let's see next. Okay, next one. It's saying two lines pass through this point, intersects each other at 60 degree. So let's first of all draw it to understand. One line, another line, they intersect at 60 degree. Okay, two lines passing through, both the lines are passing through 2 comma 3. That means this point is 2 comma 3. Okay, he's saying if the slope of one line, let's say m1 is equal to 2, he's saying m2 we don't know. Okay, find the equation of the other line. See, finding the equation is not difficult at all because we know the passing point. If only we can get m, I think it is same idea, slope point form. Okay, so the whole idea is to get m2, and this type of question was already covered in previous lectures. How to get m2? We don't know, let it be x or let it be m2 only. So angle between lines tan alpha is equal to, this is alpha. Okay, m1 minus m2, 1 plus m1 m2. This time I'm taking m2 as x, so I don't have to write m2 every time. So tan 60, that's root 3, is equal to 2 minus x upon 1 plus 2x. For modulus, I've already discussed that every time you open a modulus with variable inside, open it with plus minus. And now you have to solve for plus as well as minus. So this is what we have to solve once for positive and one time we have to solve with negative 2 minus x upon 1 plus 2x. Let's solve for positive first. Root 3 plus 2 root 3x is equal to 2 minus x. So root 3 minus 2, that becomes not root 3 minus 2, let's take x here. Let's say 2 root 3x, take x on this side, x is equal to 2 minus root 3. So x becomes 2 minus root 3, take x common, you'll get 2 root 3 plus 1, that's in multiplication, it will go in division. Okay. Similarly here also, so minus root 3 minus 2 root 3x is equal to 2 minus x. Take this one on the other side, so you'll get x minus 2 root 3x is equal to 2 plus root 3 this time. So take x common, 1 minus 2 root 3, 2 plus root 3, x directly becomes 2 plus root 3, 1 minus 2 root 3. So these are the two values of x that you are getting. Okay. Using this, you'll have to create the equation. Of course, the equation will be complicated. There's no point in that, but yes, we can generate. Anyway, it is coming complicated. What can we do? Okay. Fine. So now what you have to do, this is not complete. Okay. This is sort of a subjective question, but I'm just saying that they can merge the idea. Instead of just asking for M2, they can ask you for the equation. So equation for, I'm just writing the key point here. Passing is from 2 comma 3 and M2 is equal to x that we have already calculated. Okay. This value and this value. So one time you will generate one equation for one value of x, then another value of x, y minus y1 m times x minus x1. It's a lengthy part, just keep on writing like that, that's it. So I'm not solving it any further, but I'm giving you the main idea here. Let's look at next question. It's saying find the equation of right bisector of a line segment joining. So we need 2 points, line segment from 3 comma 4 and minus 1 comma 2. This is negative. Okay. We need to find the equation of a right bisector. What is a right bisector? It has to be right, means 90 degree, and it should bisect, means these two should be equal. Let's call these 2 points as A, B. Let's call this point as C. So if it is a right bisector, then definitely C is midpoint of AB. I mean, if it is a midpoint, what do? You do x1 plus x2 by 2. So coordinate of C will be x1 plus x2 by 2. So 3 minus 1, 2 by 2. Okay. So I'm directly writing this now. Midpoint we have already calculated a lot of time. So 3 minus 1 by 2 and 4 plus 2 by 2. That's C. Coordinate of C is 1 comma 3. Okay, 1 comma 3. Okay. How do we get the equation now? For equation, you need usually 2 things. One is the passing point that we know, C. We just calculated. If only we can get the slope of this line, and I hope you understand where I'm going with this. 2 points already known. Let's call this as M1. These two lines are perpendicular, so I'm directly stating M1, M2 equal to minus 1. Let's calculate M1. M1 will be y2 minus y1. So I'll use this as y2 and x2. So 4 minus 2, 2 upon 3 minus minus 1, that's 4, into M2 we don't know, is equal to minus 1. So M2 is equal to, this is 1 by 2, that becomes minus 2. Okay. Now we have the slope already calculated, minus 2. We have the slope, we have the passing point. I think you know where I'm going with this. Okay, passing 1 comma 3, m2 minus 2, y minus y1, m x minus x1, that's this. So this becomes y plus 2x, this is minus 3 plus 2 minus 5 equal to 0. Okay. That's your answer. Equation of right bisector. So the concept of midpoint is used, concept of slope is used, concept of perpendicular lines is also used. Everything are getting now mixed together. Okay. Star. Why star? It's a good concept. One second. This time the question is asking find the foot of perpendicular. Now what does that mean? Let's understand. Suppose you have a line and there's a perpendicular drawn from one particular point. Let's say this was minus 1 comma 3, this was negative. Okay, and we have drawn a perpendicular from here. So let's draw. Yeah, this is minus 1 comma 3. Okay, if we draw a perpendicular here, of course it will land at this point. We need to get this point. This is known as foot of perpendicular, where the perpendicular will land on it. Okay, I think this line's equation we know, 3x minus 4y minus 16 equal to 0. Okay, the moment we see perpendicular, we know we have to deal with m1 m2 m2. Okay, m1 m2 equal to minus 1. How do we get m1? Negative of coefficient of x divided by coefficient of y. Okay, into m2 we don't know, we have to calculate that. So we got m2 as minus 4 by 3. We have the slope, we have the passing point. We can get the equation of it. Passing minus 1 comma 3 and m2 minus 4 by 3. Let's get the equation. Y minus 3 is equal to slope x minus 1, so plus 1. Rearrange it. So 3y minus 9 is equal to minus 4x minus 4. So 3y plus 4x minus 5 equal to 0. Okay, that's your equation for L2. Now try to think that how can we get the equation of how will we get this foot of perpendicular effectively, not the equation of this line. Let's say this was L1 was already known to us. I've calculated L2. Okay, this is our L2. Now how do we get this foot of perpendicular? Now for this you need to recall a very old concept of grade 10th, that suppose you have two equations of a line. The point of intersection on the graph is called solution. Okay, suppose you have two equations, like suppose say x minus y is equal to 3, x plus y equal to 1. If you solve these equations by elimination and get the value of x, get the value of y, okay, the value of x and y are the coordinate of this point on the graph also. Now look at this foot of perpendicular. This is intersecting point of L1, L2. That means if I solve L1, L2, the two equations using elimination, substitution or anything, point is I've solved and get the value of x and y from those two equations, I will get the value of x and y, and that value of x and y will be the coordinate of this foot of perpendicular. I hope you can understand this. I'll write it slowly. Okay. Foot of perpendicular is intersecting point of L1 and L2. Therefore, solve L1 and L2 for x and y, and the solution is the coordinate of foot of perpendicular. Means we have to do the elimination. Okay, the easiest way is to do elimination. The equation is 3x what was 3x minus 4y equals to 16. This one is 3y, sorry, not y, we have to write x first, no? 4x plus 3y equals to 5. This is what we have to solve. So elimination, I hope you can recall. Multiply this by 3, multiply this by 4, you'll get new set of equation. 9x minus 12y is equal to 48. 16x plus 12y equals to 20. Add them. So 16 plus 9, 25x is equal to 68. Oh my god, 68 by 25. Again a fractional value. Anyhow, this will be the coordinate accordingly. The x coordinate of foot of perpendicular. Okay. No, not really. We cannot. Should we really put the value of x in this equation? I think I will prefer to solve it again. So 3x minus 4y means you know that putting the value of x here and then solving it for y will get you the value, but dealing with this kind of fractional value, I better solve it one more time. 4x plus 3y equals to 5. It's your call again. I have the tendency to do like this. This time multiply by 4, multiply by 3. The new set of equations become 12x minus 16y equals to 64. 12x plus 9y equals to 15. Subtract, change the sign, negative, negative, negative. Eliminate. This time it is coming. So minus 25y is equal to 49. So y is coming minus 49 by 25. Okay. So x comma y is 68 by 25 comma minus 49 by 25. This is the coordinate of foot of perpendicular. Okay. I'll repeat the idea because this is a new concept. So far what we have done is pretty much was the same idea about equation of line. But this time what we have to do is we have to get this foot of perpendicular. It is the intersecting point of L1 and L2. If we solve two equations, we get a solution. That solution itself is the intersecting point. This value of x and y by solving it by elimination will be the solution, and this will be the coordinate of this. Same way L1 and L2 we know. We do the elimination, we get the value of x and y, and the value of xy will be the coordinate of this foot of perpendicular. That's why I put a star on this. All right, that's done. Few more questions. 4. Okay, let's see. Remaining, I think some part will be trigo. Okay, let's see. It's saying the perpendicular from the origin to this line meets at minus 1 comma 2. Find M and C. Okay, first analyze. He's saying there is a line, first of all, y equal to mx plus c, na? So it can be anywhere, doesn't matter. This can be also y equal to mx plus c. The point is there is a perpendicular from origin. So we have drawn a perpendicular from origin. Again, you might think perpendicular from origin, this must be normal form. No. Angle, we have not talked about the angle of this perpendicular. We have not talked about the distance of the perpendicular. So no. He's saying that the perpendicular to this meets at the point, means this point is minus 1 comma 2. He's saying find the value of M and C. Okay, the equation of this line is mx plus c. Okay, so first of all, this is origin 0 comma 0. Okay, and I think after this you should know what I'm going to do. M1, this is M2, let's say for the time being, let's call it M2. Okay, now M1 M2 equal to minus 1. How do we get M1? 2 points. So 2 points by 2 minus y1. So 2 minus 0 upon minus 1 minus 0 into M2 is equal to minus 1. So M2 is equal to, put the value in here, negative negative cancels, that becomes 1 by 2. Okay, so that means this is the M of this line. So value of M is M2, na? 1 by 2. So right now the equation is y is equal to M is 1 by 2 x plus c. I've put the value of M in this equation. So this is the equation of this line, and this point lies on this same line. So that means it must satisfy the equation. Same concept as earlier. So put the value of y, 2 is equal to 1 by 2 x is minus 1 plus c. What do we get c as? 2 plus 1 by 2 is equal to c, 5 by 2. C is 5 by 2. Okay. Slope we calculated using the concept of M1, M2. Then I put the value of M, and then the point must satisfy the equation. Get the value of C also. This is lengthy. I'll discuss the idea at least. Let's do 17th first. Okay. Numbers are there, na? The last two questions are regarding proving. So we'll discuss that at the last. You are having a triangle ABC. A 2 comma 3, B 4 comma minus 1, that's negative, okay, and C 1 comma 2. He's saying that from the vertex A find the equation and length of the altitude. Okay, this is the altitude, let's call it D. This time it's altitude. Okay, and I have drawn triangle like this, so it's looking very much symmetric. You might think these two must be equal, but no, altitude means only 90 degree. Okay, so we need length of AD. We need two things: equation of AD that we can get and length of AD. All right, first let's talk about equation. I think the concept is not very tough. For AD equation, we have the passing point. All we need is slope. Same concept. Okay. M1, M2, M1, M2 equal to, I've done so many times now, M1, M2 equal to minus 1. So let's calculate M1. 2 points, so y2 minus y1, so 2 minus minus 1, 3, 1 minus 4 is minus 3, m2 equal to minus 1, so m2 equal to 1. Okay, and equation, passing point is 2 comma 3, so equation will be y minus y1, x1 y1, okay. m2, okay, 1 x minus 2, so the equation becomes y minus x, this becomes minus 1 equal to 0. Okay, equation of AD is done. This is the equation of AD, half part done. How do we get length of AD? Try to think, pause the video, try to think how can you get the length of AD. There are two ways, one is shorter, one is lengthy, but there are two ways, you should know that. Okay, thought about it? Let's discuss. One way to deal with this is actually getting the value of D, that means get foot of perpendicular that we just discussed. If you know the coordinate of D, if you know the coordinate of A, use distance formula to calculate AD. The distance formula, remember the one that I discussed in the starting, x2 minus x1 whole square plus y2 minus y1 whole square in the square root. That's a longer approach because foot of perpendicular you have already seen, this is very lengthy. Okay. See, is it like distance of this point, is it like this distance of this point from this line BC? Can I say AD is distance of point A from line BC? You have to understand, because distance is always calculated perpendicularly. You have to understand that. Means suppose this is a line and I ask you to calculate the distance, you never calculate distance like that. This is the distance. No, this is the distance, shortest. Okay. Now if you understand that, what do we need? We need equation of BC and then distance of a point from a line. Okay, so lengthy question because it has two parts inside it, but anyway, you get the idea now. So instead of directly saying calculate distance of this point from line BC, is indirectly confusing it from the language point. Okay, so equation of BC, slope we already know, we calculated na, m1 minus 1, passing point we know, take any one, 1 comma 2, so y minus 2 is equal to minus 1 x minus 1, so y plus x plus 1 minus 3 equal to 0. Okay, that's the equation of this line. Okay, now let's calculate distance. So you have a line, this is the line, and you have a point from which you have to calculate the distance. How do we calculate distance? Distance is calculated by putting the value of the point. Point was, what was the point A? 2 comma 3. We have to calculate the distance, so put 2 comma 3 in this equation, so 3 plus 2 minus 3 upon square root of coefficient of x 1, coefficient of y 1, so that's coming 2 by root 2, that's root 2 units is the distance. Okay, and that effectively was your AD. So I have discussed two approaches. One was lengthy, foot of perpendicular, very lengthy approach, but the other one you have to think about it. All right, last two questions. P and Q are length of perpendicular from origin to this line and this line. Means there are two lines. Okay. I'm drawing them separately so you don't get confused at all. One line is x cos theta, trigo is there. Okay. Y sin theta is equal to k cos 2 theta. Another line is x sec theta, y cosec theta is equal to k. I don't like sec cosec, so let's rearrange it. So x by cos theta plus y by sin theta is equal to k. If we rearrange it, so you'll get x sin theta plus y cos theta is equal to k sin theta cos theta. Okay, so that's the new equation. Okay, let's resemble it by something. L1 L2 rearrange, after rearranging we got, I'll remove this, L2 is x sin theta minus plus y cos theta is equal to k sin theta cos theta. Okay, we got two lines, L1 L2. Okay, now what is the question saying? That we have to calculate the distance from origin. Let's say origin is here 0, 0, let's say 0, 0. I'm drawing two times because I want you to analyze one part at a time. Okay, of course 0, 0 is a single point, but I'm drawing two times so you can analyze. We have to calculate the distance. This distance as per the question, perpendicular distance is P, and from the second line the distance is Q. Okay, so if we want to calculate the distance, what do? The distance is equal to P is equal to modulus of, put the value of this coordinate in this equation. Okay, so putting it in this, so 0 into anything, if we put x as 0, 0 into anything is 0, then 0 into y sin theta is also 0 if we put y as 0 now. And k cos theta should come on the left. Okay, because the standard form has to be all the ax plus by plus c should be equal to 0, right side should be 0, so this should be on the left, so this should be minus k cos 2 theta. Okay, and then denominator is square root of coefficient of x, that's cos square theta, coefficient of y minus sin theta and whole square of it. That's your P. Okay, similarly you can write Q also. Q will be again modulus of, put it 0, 0 in this equation, so 0 plus 0 x0 y0 k minus k sin theta cos theta, and denominator will be square root of same thing, sin theta square sin square theta cos theta square, so cos square theta. So we get P as k cos 2 theta, because of the modulus I am taking positive. Okay, and cos square, this is sin square, cos square plus sin square is 1, so P is equal to k cos 2 theta, whereas this becomes plus na, so k sin theta cos theta. Okay, one second, and again denominator sin square plus cos square is 1. Now the question is saying, the question is although to prove, but they can ask you what is P square plus 4Q square. So P square plus 4Q square is equal to, P is k square cos square 2 theta plus, this is again k square sin square 4 was there na, 4Q square, so 4Q is k square sin square theta cos square theta. Okay, now keeping this as it is, k square cos square 2 theta, this k square I am taking out, and I am combining 4 sin square theta cos square theta as 2 sin theta cos theta, and I can rewrite this as whole square. You'll understand why I am doing this. I have done 4 as 2 square, sin square theta cos square theta, I have combined them together and I have written them in a whole square, 2 sin theta cos theta whole square. What is 2 sin theta cos theta? Cos square 2 theta, that's sine 2 theta, and there is a square, so sine square 2 theta. You take k square common, so you'll get cos square 2 theta plus sine square 2 theta. What is cos square again plus sine square with the same angle? 1. Done. Hence proved. Okay. All right, we're done. Last part, last question. Same idea. He's saying P is the length of the perpendicular from origin again to a line whose intercepts on the axes are A and B. You should know directly. This is intercept form. Intercept on the x-axis is A, y-axis is B. So the equation is x upon A plus y upon B equals to 1. Okay. Let's keep it as it is. Let's not take LCM. You'll see why. Okay. Now, if I want to calculate distance of this line is already, we know, x upon A plus y upon B is equal to 1. If I want to calculate the distance from origin, I have to use the distance of a point from a line. So how do we do that? Distance as per given the question is P is the distance, modulus of, how do we do? Put 0 comma 0 in this equation. So 0 by A, so 0, 0 by B is also 0. Take 1 on the other side, minus 1. Okay. Upon square root of coefficient of x, 1 by A square, coefficient of y, 1 by B square. Do the squaring both sides. So why? Because P square we have to generate. So P square is, because of the modulus, this will become positive. So 1 upon 1 by A square plus 1 by B square, and do the reciprocal on both sides. So 1 by P square will be equal to, reciprocal of this will be 1 by A square plus 1 by B square. Not too much to solve, but you have to know the direct format because of the intercepts, and then apply distance from the origin. So how do we do that? Put 0 comma 0 in this standard equation, modulus divided by coefficient of x, coefficient of y square in the square root. Finally done. Okay, so we have done a lot regarding straight line now. I hope the concept of parallel and perpendicular are clear to you, because we have discussed a lot of questions based on that. m1 m2 equal to minus 1. I mean, you just look at the times that I've written that condition. Okay, fine, we're done for this. See, the concept never ends effectively, but somehow there is a restricted amount of time also, so we can still do a lot of different types of questions are there depending on the situation, but I think this pretty much summarizes the whole idea regarding the straight line. You know now how to calculate slope for different lines, you know how to calculate equation for a certain line, and how to use the conditions of parallel and perpendicular mainly. Okay, and other things also. Fine, that ends your chapter for straight line. Okay, we'll start with a new chapter in the next class. That's it for today. Good day everyone, see you in the next class. Bye.